Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. I'm going to continue on the same topic, which is your SF and BM calculations. But I'm going back to the concepts actually. I had not given you the complete concepts initially when I started making the first video. Then the second one was a numerical. I thought I will go back to the concepts because there are more things for you to know when you calculate your SF and BM. I'm still sticking on to only the beam, the basic structure. I'm not going into box. There are two reasons for me to go back to concepts. Number one was since I had not done completely the concepts, I thought I'll give you the basics and then I can go for the problems. But the rest of the concepts are also needed for you to complete any problem because it is sometimes confusing. I've seen a lot of students get confused how to solve a problem. So I thought I'll complete the concepts. There are a lot of them, so I've tried to make it a little bit simple. Few things might be repeated, but majority of them is something new which I've not given you before. At the same time, there was another big reason for me to give the concepts. It was regarding a feedback from one of the candidates or the viewers who mentioned that different institutes are teaching in different way. And his suggestion was that we all should teach in one way. That is a single way. So for that, I have a small answer. And once I finish the answer, then only I'll go to the concept. The reason being that why you can't expect everyone to teach you the same way. I can't give you the answer in just one single sentence. That is not possible. So that is why I am going to go a little bit long way. When I say long, long for that person who uh, suggested that all the faculty should sit in one place and learn in one single way and teach in one single way. So let me just try to justify whether that is possible or not. Let us see that. If you look at a geometry or if you look at a stability problem, you should have realized that you can get the results in different methods. I'll just give you a simple example of stability. If I give you a problem for loading, I can find some details with initial displacement and final displacement also. But at the same time, I can do it with sinkage or iceage and the TPC as well. Does it mean that you should be taught in one single way? Answer is actually no. You take a simple chartward problem of counteracting method. Depending on the data, you can do multiple ways. So it is not that only one way should be taught to you. If I give you a passage plan, the 40 students will have 40 different courses and distances. Does it mean that somebody is correct and somebody is wrong? No, I don't think so. For me, all the 40 passage plans, even though the departure and destination was exactly the same, the chart was same, that means all of you are correct. It is your own perception whether your passage plan was slightly better than the other, but actually all of them are right. If I give you similar cargo and a similar ship and I ask all of you to load, do you think your storage plan and the final GM will be same? Answer is no. This is, I think, something even more which is related even if you are in ship or no. You can go to 10 biryani shops and I'm sure all of them are called biryani, but all of them will taste different. and each one is known for its own taste. So can you ask the 40 cooks to come to one place and learn from one chef and do exactly the same? I don't think so. You have a medical issue. If you go to a doctor, I'm sure he'll give you one method of treatment. But if you take a second opinion and third opinion, I think all of you know, and you would have seen this among your relatives also. Each one will be different. Aren't they getting the same MBBS degree or the MD or whatever qualification they have? So does it mean that all the doctors should come and sit in one place and do the exact diagnosis and exact results? No, that is not possible. Basically, all of us and you, we are all going through the same syllabus, same curriculum, same certification. But your approach has to be different because each one of you are different. It is not possible to be the same. Can I say your safe speed and the other man's safe speed are exactly the same? Two people have read or gone through the Colrex exactly similar. The Colrex is still only one Colrex. So you'll be going on guidelines. So you can't quantify and you can't say that this person is right in his answer and the other one is not. What we do is we try to give you a very common method so that you can solve all the problems with one way, just one way. And it has to be constant approach. The sequence should be same. That way the students are less confused. But I do agree when you go and look into various videos, I would have taken a problem just for the sake of this SFBM. I would have taken it from left side. Somebody can do it from right side. The answer should be still the same. Can you tell that all of you should do this? No, you can't. Why? Because answer is still the same and they are all correct. There's nothing wrong in approach. So whatever you choose, that depends on person to person. So whatever teacher chooses also, it is as per his what he has understood and the way he has been taught, the way he found out it was easy to understand, the way he found out it will be easy for you to understand. So that is what we choose. So we cannot say something is right or wrong. It's just a different way of looking at the same problem. Before I go into this concept, I would like to ask one question from you people also, because you're free to give feedback. Even after this video, you're free to give feedback. I am teaching 40 students. Let us say I'm taking a chart work. I'm teaching 40 students, all of them with a single method. When someone does not understand, I have to change my method because he finds it easier that way. But let us say I don't change, I give a single method. All the 40 of you in a classroom have listened to the exact same lecture, the exact same wordings. But why is it that each one of you solve the questions differently? The answers are different. The marks are different. If from a single teacher, 40 people can behave differently, how do you think everyone who teaches also is going to teach the same way? So it is not possible. I hope the person who gave the feedback should agree with me on this. We'll try to see, and each one of them have got their different way, so please accept it. And you choose which is easier for you as far as the results are correct. Then you can follow any method and you will get the marks. I hope that satisfies uh, the explanation at least. I'm going to go for the concepts. And you will see when I'm showing the concepts itself, I'll give you multiple ways of possibilities. That is the whole idea. You pick your method which is easy for you, which you are able to solve easily, understand easily, and please follow that. Let me go back to the concept right now. As I said, this module is going to be only concepts. I'll come with the next video with a problem. And that time I'll try to stick on to all the concepts which I'm trying to tell so that when I give you a solution, you can always remember which concept I am using. And you will see if I use two different concepts, they should give me the same answer. The answer should be same. If there's any change in answer, if there is some mistake, we will correct it. That is okay. Everyone is liable to do mistake. So that doesn't mean somebody who teaches cannot do a mistake. People can do mistakes, let them correct it. But at least let us follow some set standards. And I will follow one standard that I'm going to tell you today. Let me follow that and I'll try to solve all the questions that way. The reason being, I've seen videos where part of the question somebody solves from left hand and suddenly he stops and he starts using the right hand. And that is where the confusion starts. But actually the concepts are right. Still it is correct only. It is the way he has understood, the person who has taught. So I hope this one standard method which I am going to follow will help you in the rest of the problems. I've been trying to follow the same thing. Let us see. A few repetitions. Whenever a beam is in static equilibrium, all the resultant forces should be zero. And usually I will take a point and we'll do the algebraic sum on one side. And all my questions, usually it is left side only. That is what is our DG shipping and MMD exams they expect. Why? Because the books are being followed by that. But there's nothing wrong in going on the right side. You should get the same answer actually. You should get the same answer. But what you are supposed to achieve is all the reaction forces should be equal to action forces. In other words, this is the equation. Reaction minus action should be zero. Let me show you a small beam and let me take a small section where I'm standing. So for me, this is left. And if I have a force in this direction on the left and on the right side, if I have it in this direction, this is called positive forces. This is called positive forces. If I give you in a slightly different way, this is the one more way of telling it. You can see both these forces are trying to give me a clockwise rotation. So you remember whichever way you want. Either remember clockwise or remember arrow up on the left and arrow down on the right. Whichever way, it's okay. There are multiple ways, so please accept it. I'm giving you one more where on the left side the arrow is down and the right side arrow is up. Then it is called negative. And as I said, I'm going to use only the left side convention. So when I say left, in both these pictures, I'm going to take left, which means upward force here. This is what is on the left. And the downward force, which is negative, this is what is on the left. So I'm going to take all the equations starting from left and I'll move towards right. So that means I'm going to do algebraic sum only on the left side. And again, I'm repeating, if I do it from the right side also, I should get the same answer. It might be confusing a little bit, but you should get the same answer. This is exactly the same diagram, which is showing what I've shown in the previous one. I'm going to take the left. So up is positive on the left and down is negative on the left. Let us go to BM. BM is the one which causes a lot of confusion. You'll see SF, usually not many people will do any mistake, but BM is the place where a lot of people will do mistake. So what is bending? Bending is nothing but a load and a lever. So it creates a moment. So that is why it is called bending moment. And again, this is a repeat. When you have to be in equilibrium, all your clockwise moments and anti-clockwise should be same so that they can cancel each other. Here again, I can do bending moment from left side or right side also. I can do both sides. As far as you have this equation satisfied, I think all your problems will be correct. Again, for you, for BM also, there is a sign convention, just like what we had for SF. So I'm going to show you what is the sign convention. I'm taking a small diagram. I'm going to give you a bigger diagram also. Let us look what is positive. Positive means the leftmost picture, clockwise on the left of that, and anti-clockwise on the right of the same beam. And this is what is called positive, which gives you a sag. I've shown you both sides. Then what is negative? Negative is opposite to these two. You can see on the left side is anti-clockwise, on the right side is clockwise, and this will give you a hog. I'm going to show you a couple of more pictures so that you are very clear, because you can tell in slightly different ways also. Slightly different ways also. I'm going to show you both of them. This is the same picture. I'm going to show you in one more picture where, let us say, dynamic loads of your waves are acting on your vessel. So it's exactly the same thing. This is what is called sagging, and this is what is called hogging. Now, I'm going to show you one more way which a lot of people use for calculating of bending moment. It is the same diagram, but please see how I am changing the view. This clockwise and anti-clockwise direction of right and left was one of the way of telling. Now I'm going to show you the second way. Please see here what happens when you sag. Your top part compresses. So people use this also. They say, where is it compressing? So if I say compressing on the top, then this is what is sagging. And there's an elongation on the bottom. Similarly, please look at hogging. You have elongation on the top and the compression on the bottom. So please don't be surprised when somebody makes uh, videos or tutorials, or maybe somebody teaches in the class. He can use this also, a compression and elongation, to tell whether it's sagging or hogging. Or he can use this clockwise, counterclockwise directions at the ends also. Both are same. So the same thing. Let us look at a few clues and conditions, which I had not mentioned in the last or the first video which I made for SFMPM. You will see that we will always take actions as weight, which is actually going downwards. And why I called negative is because I'm going to choose left side. And I told you anything going down on the left side, please remember, is negative, force acting downwards. Then what is reaction? Reaction can be equated to buoyancy. Buoyancy are plus on the left side because force are acting upwards. Let me give you a few more clues. These are all basic clues. There are more, but you need at least these two. Two of them I'm going to show you. Whenever SF is a horizontal line, your BM will be a sloping line. So I'm showing you here. You see, this is your SF horizontal. This is your BM, which is sloping. If SF itself is a sloping line, you see SF itself is a sloping line, then BM is not going to be straight. It is going to be parabolic or curved, whatever you want to call it. It's called parabolic or curved. So you can see this is a curved line. So when you draw SFBM diagram, you have to be careful to just see what is the trend of your SF. And please do it with a freehand sketch also is possible. Where is a straight line, use your scale. Now, one more important thing. Wherever this SF crosses 0, here, your BM will be max. Here also SF crossing 0, your BM is max. Whenever BM reaches the peak value, it's very evident that it's going to change the direction again. So that is what is happening. Whenever the peak has reached, the BM curve has started changing the direction. There can be multiple peaks of BM. Why? Because the SF could be crossing at various times for 0. So I'm showing you one example here. Your SF has crossed 0 multiple times. So you will have multiple peaks. The sign of the BM is telling you whether your beam will sag or hog. And this is a normally sign convention. Sag is positive. It will look like this. And hog is negative. It will look like this. Right now, you can see on this diagram on the right side, you can see the BM is more on the negative side. So majority of the vessel is hogging basically. Let us look at this one more character of your SFBM. Wherever you keep a concentrated load, you will see there'll be a sudden change of your SF. Whenever you have sudden change of SF, it is possible that it could cross zero. You might have a peak. So whenever you have a peak of BM, that also is going to change direction. Whenever a uniform load is there, you call it UDL, uniformly distributed load. You will see your SF and BM curve will do only gradual change. There will not be sudden changes. Okay. BM can be calculated by moments method. That is what I am doing. But you will see majority of the people will use area under the curve. They will try to integrate the area under the curve. Now, why I chose that? Basically, they both are same. In your normal beam structure, you will see the diagram of SF are quite uniform. And for you, you can very easily do the integration. So instead of doing that integration, I'm doing it with moments, just multiply, which is exactly the same, which is area. I'm trying to multiply the force into the lever, which is area, basically, area under the curve. Now, when you go for your box-shaped vessel with a loaded cargo, it is preferable you do only area method, because that time trying to calculate using moments method may not work out because of variation in the load. So there'll be sudden change of variation or gradual change of variation. Why? Because you have a cargo. The cargo maybe is in the form of a cone. So you will not be able to do with moments method. Since I'm doing only beam, I'm sticking on to the moments method, which is exactly the same. Let me just quickly show you. Assume you had a SF curve and somebody is asking you to calculate BM at point delta. I'm going to use a paper like this. I'm going to close the rest of the points. Since I'm going to use only the left side, you can see I'm closing till delta, and each frame is 1 meter. You can see 1, 2, 3, 3 meters into 50 newtons. You have found the BM by area, but it's exactly the same thing which I also solve. I stand here, I look at the lever and look at the force. So 3 into 50, which is exactly the same. So I'm going to stick on to the moments method of calculating BM, and nobody can stop anyone from doing the integration method. So this is two methods here itself. So I can keep moving this page. Let us say I want to calculate up to Bravo. I could have done 1 into 50, which is exactly the area under the curve. This is what you do in your stability calculations also. When you go for your GZ curve, you're multiplying the GZ into the angle. That is what gives you the dynamic stability also. So I can keep moving this frame and I can calculate using area also. Choose your method. If you're comfortable with area, please go ahead with area. But I am going to stick on to the moments method, which is exactly the same. It's easy for me to calculate. I feel it is easy, so I teach the same way. I'm going to stick to that. Let us quickly look at a few summary of SF calculations. Again, this is one more method of SF calculation. Otherwise, normally what we do is we just look at the force, look at the other force, and we do algebraic sum. I'm going to show you one more thing, how you can figure out whether this SF is going to be positive or negative. Please see this. I'm giving you a beam which is free, let us say, which is free to rotate at the pivot, and I give a force. You can see the force is going downwards. And when you start looking at, let us say, when you start looking at the forces on left or right, you will realize one thing that is going to happen here. If you look at this place, please see what this beam can do. It is able to rotate clockwise. And when it is able to rotate clockwise, you will realize that you will get something called positive. This is the second method. If you are confused with this, please don't do this. Please use the normal method which I am teaching you. But this is the second method. This is also a method. A lot of people show this in the videos. They animate as if they put the force and show you how it is rotating, and they give the answer as positive or negative. I'm going to show you why I would call this positive. Let me just show you a little bit while. Let me show you what is negative. Anytime you have a force like this, you will see It'll try to rotate like this, which is anti-clockwise, so it's negative. If you realize, when I was telling about the direction of SF and BM, I told you whenever I have a clockwise kind of motion because of the forces, I can call it positive. When it is anti-clockwise, I can call it negative. How do I prove this? I'm going to put one arrow. This is what is going to happen. This is somewhat like this. So this is also one more method, but I leave it to you. If you feel this is confusing, please do not follow this. Go by your normal actual method, which we are already doing. So please go by that. But these are the ways. So multiple ways are there. I'll give you some more clues also. I'm going to give you more clues on BM. Why? Because as I said, BM is more confusing. This is a repeat. The point where SF crosses the baseline, BM is peak, and it is always many times asked in the question to find what is the peak value of the BM and where is it occurring. So there are two ways of doing it. You can do by interpolation also, you can do by graph. Again, you have a choice. Please choose which is easier and which is valid for that question. Usually you will see, which is the normal condition, BM will be maximum farthest away from any support. But this is valid only for multiple support structure. When you come to cantilever, this is not valid. So you'll have to change your approach. It is not possible for you to stick on to only one method. It's not possible. There's one more thing. When in construction, wherever the BM is max, they always try to give a support to reduce the BM in the structure. So that is also a clue that where you need, you want to give a support also. Let me give you a couple of structures and what is the possible BM. There are some fixed structures where you can remember these points. I'm going to give you for simply supported. This is simply supported. And you will see that the BM at both these ends are going to be 0. And this beam is going to behave like this. Let me go to cantilever. The left side of the structure is fixed. It does not allow you to move. So you will see the BM is max at the fixed end. BM is 0 at the free end. And this particular beam will try to do this. Let us go for an overhanging beam. This is an overhanging beam. Here, BM is going to be 0. Other end also, BM is going to be 0. And then you will see this place, the BM is going to be max. This particular structure, if you break it separately, it might look like this depending on the weights. I cannot guarantee this, but it's possible, depending on what is the weight. Let us look at a single support overhanging beam. This is only single support. It is somewhat like your seesaw. You will see BM is going to be minimum here, and max here. And this will look as if it is doing this. So my concepts are over for now. And I've chosen only those concepts which were basic and enough for you to start a problem, but with choices. So my aim here was to give you choice and allow you to choose whatever you want. So the next video which I'm going to make, I will try to solve a problem using the same concepts, and let us see how we approach that. And as usual, you have the freedom to choose and you have the freedom to give me feedback also. If you feel I can change something, I'll surely do it, and that is what we'll do. Keep watching Jal Prayag. Until I make a new one, I'll catch you soon.